Hello, this is Dr. Hassan Abdullah with the course Complexity and Analysis of Algorithms. So, the topic which we are covering is greedy algorithms, which is topic number 6 in our course outline. So, lecture 6C. C is the subtopic which is strengths and limitations of greedy algorithms. So, this video course is supplemented by the material available at easymcq.com/goget. And this is a personalized learning management system. How come it's personalized? Because you can set the pace of your learning or the route of your learning. So it's personalized. How you know it? You should need to watch this video. And personalized user interface as per your liking, color, font, size. Maybe it suits you. Maybe there are certain limitations. So that's personalized. How? Please watch this video. And personalized online exams, which gauge your learning and evaluate it also. This is the video. And other videos, multi-level format questions, powerful search, these two videos, and of course animations and videos, this video. So all these videos are available on my YouTube channel and also on Canvas. So just type my name, Dr. San Abdullah, on YouTube, and you will reach and get all these videos. So now we take a brief look at the course outline. So the course outline consists of 11 topics, and these are cutting edge contents. Contents are not old content, it's new content. And we are right now doing greedy algorithms. And of course, I will also do advanced algorithms, in which I'll do randomized algorithms, approximate algorithms, and genetic algorithms also. So this is just a brief intro. So now we move on to the supplemental website. So we are at the supplemental website, and in the first two videos, 6A and 6B, 5 questions were covered in each lecture, each video. So now we are at the lecture number C, or third lecture in the series. So we start with question number 11, and this is the same example which we had in the previous lecture, but now the solution is going to be different. It's going to be an optimal solution. Okay. So, if you recall, in the previous video, we adopted two approaches. One was the longest job first, and the total time was 35 units. And then we use the same data set. We use the shortest job first, and the total time taken was 40 time units. So there's a deterioration. So now let's see if what will be the optimal one. So how would we know the optimal? That's the big question. And what others optimal solutions are possible, and how to find the optimal solution. So all interesting questions. So my claim is that the solution is clearly optimal. So how can I make this claim? Okay, it's very simple. It's simple because we see that this is 34, okay, and the total time taken is 34. The time taken is 34, okay, and the time taken is again 34. So there is no wait. There is hardly any wait. Okay, there is no wait. There is no waiting. There is no waiting. So this is the optimal solution, guaranteed optimal solution. And are other optimal solutions possible? Yes, they could be possible. Possible in the sense that the scheduling of the jobs could be different, but the time taken is not going to change, because this is the optimal time. And how do we find such a solution? It's not a easy answer, because this is a difficult problem. Okay, and the only possible way is to do a brute force approach, which is not going to be desirable when the problem size is large. Okay, so that's it for this example. So what are the advantages of greedy algorithms? So we see that in the previous lecture we saw that there are certain problems, about 6 or 7, which can be solved optimally with the greedy algorithms. So what are their advantages? Simplicity and ease of implementation. It's very straightforward. You just pick the local optimum choice. Okay, so it's very simple, and there's no smartness here. There's no complexity here. So it is easy to implement also. Efficient time complexity. The only overhead is sorting. So which can be done in n log n time. So it's not n square even. Optimal solutions for certain problems that we already discussed. Less memory usage. We can have a non-recursive implementation. So recursion, because it's straightforward simply, so we can have an iterative implementation also, which is low on memory overhead. Easy to analyze and prove correctness. Once we have a solution which is optimum, okay, then it is not very difficult to prove the correctness, which we will do in the next lecture. So, so we see that the greedy algorithms have a relatively lower time complexity, okay, lower time complexity, and they are as compared to other optimization algorithms. such as, of course, exhaustive search is undesirable. It can degrade to a brute force. So it takes order e log e time, okay, where e is the number of edges. And of course, it is optimal for certain problems. For example, for fractional knapsack problem, it guarantees an optimal solution when solved greedily. Of course, it doesn't have optimal solution for the 0 1 knapsack. Less memory usage as compared to dynamic programming, okay, since they process one decision at a time, okay, and does not require additional data structure for storing the intermediate results, okay. Easy to analyze and prove correctness because they are guaranteed to work when they do work, okay. So proving is fairly straightforward. So of course there's a question and corresponding answer about this. So what are the limitations of the greedy algorithms? As I said in the beginning of the lecture, that the correct wording should be greedy technique. So not always optimal for all the problems. For some of the problems, 6 or 7 which we have discussed, yes, but not for all the problems. Not for all the problems. Local optimality may not lead to global optimality. That is the reason why it is not optimal for all of the problems. Greedy algorithms may not solve all problem variants. And say, for example, even when it works for knapsack problem fractional, it does not works with the variant of the 0 1 knapsack. Hard to generalize. Again, this can be applicable that the fraction knapsack cannot be generalized to 0 1 knapsack. May require sorting, and sorting has its overhead also. For example, if it's like quicksort, it can be n square. Risk of missing the global insights. This risk is a very realistic risk. That is why it is not always optimal. So let me clean this and we move on to the details. So local optimality may not lead to global optimality. That is one thing. So because in certain cases, globally optimal solution requires considering future consequences of decisions for which greedy algorithms fails. Future consequences, there are no future consequences. Okay. Some variants require more complex solution with greedy algorithms which cannot handled by them. Okay. Hard to generalize. This is the against the property of the algorithm because the algorithm should be generalizable. Require well-defined strategy for making local choices. Okay, so sorting can be n log n, right? Okay, and it itself may not always be the most efficient for small data sets, right? Because there's the overhead of handling the constants and everything. So risk of missing global insights. Do not always examine the broader structure of the search space, and of course, so it overlooks the patterns, which might result into a better global solution. So that is missed altogether. So if you're interested, here are the additional references. So how can greedy algorithms get stuck in the local minima? So all these issues, why do these issues occur? I'll show you using a picture also. So making short-sighted choices because it's the immediate choice. Myopic approach. Here is the myopic approach. Lack of global view. There is no global view. And decisions based upon the local information. So this is explained here. And for example, lack of global view, decision based upon the current situation without considering how these decisions may affect future steps, which is the case for traveling salesperson problem. The greedy approach will choose the nearest unvisited city or the point and will not be able to minimize the overall distances because it could have taken a longer path. And that once that longer path is taken, then optimization cannot be guaranteed. And myopic greedy algorithm might color versus one at a time by choosing the smallest available color, but can leave some verses with no valid color due to earlier choices. Okay. Decisions based upon local minima or local optima, ignoring the global structure of the problem. So this is a multi-dimensional search space. The search space is multi-dimensional, and we are looking at a two-dimensional space. So the objective is so it minimizes the function, reaches this point. Okay, and then further processing of this function, multi-dimensional function, results in increase of the objective function, which I show by red color, right? So when there's an increase in the objective function, then this is a greedy approach, does not look at the global. So it will not take this choice. If it would have taken this choice and covered this plateau and like gone uphill, then would have reached the global minima, hit the jackpot. Not possible with the greedy approach. We'll never do that because it does not look at the long term approach. So how greedy algorithms avoid getting stuck in local? So if this is the problem, how do they get avoid getting stuck in the local optima for certain problems. First is the greedy choice probability, which works, optimal structure, which works, and the global optimality with correct greedy heuristic. So the heuristic was selected, the correct one that results into reaching the global optimal. And lack of backtracking, because this backtracking can cause play havoc. It can result in a brute force approach. And what happened was the problem structure compatibility. Certain problems certain problems have structures that make them usually suited for a greedy algorithm. If it matches, then of course it just gets out of the local optima. And lack of backtracking actually speeds up finding the optimal solution, because this backtracking basically can kill the performance. So that's all I have for this sub topic. And the next topic, that is 6D, we will finish this topic of greedy algorithm. Thank you very much.